Okay, this is a really hard problem. What makes it harder is that it's so much harder than everything else we're doing. I think they must have got this from the University of Washington or somewhere. They just kind of threw it in there. So it's definitely worth doing, but don't worry, I would probably not put this on a quiz. Maybe a homework now that you know how to do it, but I guess I did put it on a homework, didn't I? But I would never put this on a quiz. All right, so look, north, south, east, west. Okay, so here's joint base Lewis McChord. Think of that as the origin. Here's A. This is this undisclosed location, 235 kilometers east, 149 south. Now here's Rainier, 56 east, 40 south. And so what you want to do is you the overview is we're going to find the equation of L1. We can do that because we know the slope. Now here's the hard part. L2 is actually perpendicular to L1, and that's not obvious at all unless you think about it. This Rainier is supposed to be as close as possible to this pathway, right? So if you just think about all these possible distances, the distance where Rainier is closest to this pathway has to be perpendicular to this line. So that's important. Okay, so we're going to find the equation of L1. We're going to find the equation, and then use the slope to find the equation of L2. It's perpendicular. Then we can see where those two lines cross. Once we see where those two lines cross, that's a point. We're almost done. Once you know the coordinates of that point, you can use the distance formula to find this distance here. This is how far the plane's traveled. And then finally, if you know how far it's traveled, you could use distance equals rate times time. Because if you know that the plane's traveling at 800 kilometers per hour, and you know the distance, you can solve this for t. So it's quite complicated. So here we go. You ready? So we're going to first find the equation of this line. This line goes to the origin, so the y-intercept 0, and the slope is going to be negative 149 over 235. That's not too bad. Now the fact that this line here is perpendicular to that, we know a point on the line, and we know the slope. The slope's going to be positive. The slope's going to be positive 235 over 149, and the point's given to be 56, negative 40. One problem here is when you're computing these things, you're rounding. So, I kept a couple extra decimal places, but hopefully it's going to be. You might want to keep some extra decimal places. Okay, so we know the slope and the point. You can use the point slope formula. You can plug in the point and the slope, and you can solve this for b. I get b equals negative 128 over 32. It's way down here someplace. So now I have this equation. Now, to actually find where they cross, I just graph these on Desmos. I just graph this equation, and I see where they cross. You could do it algebraically. It would be really messy. So I would just enter them both on Desmos. This is what I get. The point where they cross is 58.031 and negative 36.794. We're almost done. Remember, once you know the point where they cross, we want to find the length of this line segment. It's the distance formula from here to 0, 0. Remember what the distance formula says. The length OB from here to here is going to be the difference in the x-coordinate squared plus the difference in the y-coordinate squared. So I get this. This is what I get here, about 68.71 kilometers. Now that we're almost done, now we're basically going to finish it up. So using distance equals rate times time, if it's flying at 800 kilometers per hour, time equals distance divided by rate. So you get this many hours, and then if you convert that to minutes by multiplying by 60, I get about 5.15 minutes. Now your answer might vary a little bit if you round, but isn't that fun? It was not fun. No, but I honestly think that the better question would be, how did you approach it? This is really what you should be thinking about, because this kind of reasoning happens in the future. Draw a picture. That's really the key. Then ask yourself, what are we supposed to be learning? Oh, we're learning about equations of lines and applications of linear functions. And the thing that really would be the point that makes it really hard is you have to reason that this line has to be perpendicular. You may get to a stopping place and you go, I don't have enough information. How do I? But it turns out That is probably the hardest part, is realizing these have to be perpendicular. If this is the shortest distance from Rainier to the pathway, this line has to be perpendicular. So you can find the equation of that line. Once you get this point, the rest is pretty easy. I know you'd like that. All right, hope that helps. Bye now.